like slope. The weird thing, it only works once. The weird thing about a here on a logarithm is a can be here, or remember from the other day when I talked about logarithms, a can also be an exponent up here. Remember, you can take the exponents and move them back and forth? We'll talk more about that tomorrow.
But you gave us this formula the other day, didn't you?
Right.
Wait,
but
h is the changing whatever.
Not anymore, because they've switched places now. On an exponential form, Amanda just skipped ahead very well. On an exponential equation, h is your changing asymptote, but now that we're switching everything, that's going to be k's job now. So let me show you, give you an example. We're not going to worry about a this time. Okay, so
curve the final like 0.
if you ask me another question that's not directly about logarithms, I'm going to make you eat a marker. Now, so for example, y equals log base 3 x plus 1
minus 2.
Okay, minus 2. You know what? We're going to go with Nimi's example, since I was just making it up anyway. Now, here's how I graph logarithms. You really need to pay attention on this. The steps are simple, but it's a little bit confusing why it works this way. Okay, what is this parent function? Remember, the parent function is one where a is 1 and k and h are 0.
Oh, y equals
1.
Well, you don't have to write the 1.
No, y equals...
Is the log base 3 going to change?
No.
No.
Is it on a parent function, is it ever shifted left, right, or up or down?
No.
No.
No. So it's just y equals log base 3 of x.
Well, would you add the...
Now, I'm now going to show you a step that you may skip once you're comfortable with skipping it, but I'm going to insist you do it first, okay? What's the inverse of the parent function?
Wait, what about the rest of it?
Stop. What's the inverse of a logarithm is always a... Inverse of a logarithm is always a...
X and Y.
X and Y.
They're all x and y. Inverse of a logarithm is always a...
Exponent.
Say it, Sarah. Exponential function. Logarithms are the inverse of exponents. Okay? The base of the logarithm is always the same as the base of the exponential function. So what do you think the inverse of this has to be?
3y. Y3.
Until you can put it in the right order.
Is the x the exponent?
So it's y3.
So it would be...
Brian?
3y.
What?
Stop, Nimi. If you guess again, you're done.
I really
Yes.
do think I know. Alright, would it be x plus 1?
Nope. Just of this parent function. Turn this into an exponential.
Alright, x equals log 3y.
There's no logs in it. Nimi?
I said 3y.
3y is wrong. 3y means multiplication. You need to say it correctly.
3.
And actually, no. The inverse of the parent, guys, is going to be y equals 3 to the x.
Y equals 3 to the x.
Equals y equals 3 to the x power.
So all you just do is take away the log.
All you do is take away the log, and you've got the inverse, as long as there are no shifts or anything. Okay?
Then whatever happened to rearranging...
Stop. We're skipping those steps.
Well, how did you write the first one? Because the parent function looks like it's a big x, not an exponent of the 3.
The parent function is the same as this without the shifts.
So it's a big x.
That's an x.
Oh my God.
Okay? The inverse of the parent function is going to be the exponential function with the same base.
Okay,
Alright? Now, take a deep breath. None of these steps are hard, but putting them all together is going to take a few minutes first time. Well, you just have to follow along for now. I'll have to talk later. I don't have time, and I'm going to finish this and not change the homework. Okay? So, hopefully you can follow the steps. Now, on the parent function, y equals 3 to the x. On the inverse of the parent function, excuse me, what are the 3 points I am interested in?
0, negative... No, negative 1,
Negative
0,
1,
and 1.
And what will the y coordinates be?
1, 3, and
1/3?
1/3.
Put in 0, what do you get?
1.
1.
Put in 1, you get
0.
3.
3.
3. Nimi, you're done guessing for a while. Stop. They're too wrong.
I see she
Okay?
gets a marker.
You're closest to the microphone, and you're wrong 4 out of 5 times today. So stop. Okay? Now, on the inverse of this function, y equals log base 3 of x. To invert, not to make a reciprocal, not to make opposite, what will these points be?
1/3,
Let's see.
1 and 3.
1/3, 1, and 3 will be the x values.
1, 0, and 1.
Negative 1, 0, and 1. Okay, now, take a deep cleansing breath. Last step before we graph.
The negative 1 doesn't look like a negative.
You'll live, and you'll make it clear in your own notes. Now, thank you.
TV.
I think they'll be clear. They'll have figured it out by now or not. Y equals log base 3 x plus 1 minus 2. Okay?
What are you doing?
It's the same thing earlier.
A third one, why?
Now, shh.
Oh, so it's just another...
Guys, okay? X plus 1. Intuitive or counterintuitive?
Intuitive.
Counterintuitive.
Counterintuitive. It's in with the X. It's snuggled up with the X. It's counterintuitive. So this means minus 1, right?
Wait,
Wait,
what's the
you
other
always
X
switch
and Y we're doing?
Yeah,
Pardon?
counterintuitive.
The actual function that I started out wanting you to graph. Okay? So, subtract 1 from each of these X's. What is 1/3 minus 1?
What?
Subtract 1 from each of these X values. What is 1/3 minus 1?
Negative 1/3.
Negative